The conjugate just means that we change the sign. So I'm going to change this to a big multiplication dot so that I don't need to rewrite that fraction again, and I'm going to multiply by the conjugate. But I can't just do it on the bottom. I have to also multiply by the conjugate on top so that I'm not changing the value of my fraction, because when I'm multiplying by anything, a number over itself, its value is 1. So this is like I'm multiplying by 1. But I'm multiplying by the conjugate on the top and bottom to try to eliminate the radicals in the denominator. All right, so let's do it. I've got to distribute. 5 times 3 is 15. 5 times 6i is 30i. On the bottom, I'm going to FOIL. I'm going to do first and then outer, 3 times 6i, and then inner, negative 6i times 3, and then last, negative 6i times positive 6i is negative 36i squared. That is going to simplify because I'm going to combine like terms. So I'm going to have 15 plus 30i on top. On the bottom, I'll have 9, and then my plus 18i minus 18i is going to cancel out to equal 0. So I have minus 36i squared. But we know that I squared is equal to negative 1. So I'm going to replace my I squared with a negative 1. So I have 15 plus 30i over 9 minus 36 times negative 1. I'll write it down here. So I have 15 plus 30i over 9 plus 36, which is 45. Now, you might notice something about all of these terms. I've got a 15, a 30, and a 45. All of these terms are multiples of 15. So I could, let me go one step further, I could rewrite and write this as 15, and this is 1 plus 2i, right? I factored out a 15 out of that top. It's kind of like undistributing, right? The opposite of distributing in, I'm taking it back out. And on the bottom, I could rewrite my 45 as 15 times 3, and then these would cancel. So my final answer would be 1 plus 2i over 3. Right, so that's after multiplying by the conjugate, combining like terms, replacing the I squared with negative 1. Right, we did that here. Then we added the bottom because a negative times a negative equals a positive 36. So 9 plus 36 gave us 45. And then these were all divisible by 15, so I took a 15 out of the top. And the way that you can check to make sure you factored out properly is if I distribute this back in, I would get this. So 15 times 1 is 15. 15 times 2y is 30i. So I just factored it out. And then I also factored out a 15 on the bottom so that I could cancel my 15s, because 15 over 15 is just 1. And that's what I was left with. So we're going to do one more. And we're going to follow the same pattern. So we're going to start by, we need to get rid of the I in the denominator because it's a radical and they're not allowed in the denominator. We're going to start by multiplying by the conjugate, which is 5 minus 5i and 5 minus 5i. I'm going to change this into a big multiplication dot. All right, on the top I'm going to distribute. So 4 times 5 is 20, and 4 times negative 5i is negative 20i. On the bottom, when I do my FOILing, I know from looking at this and from when we did it before that my outer, when I did 3 times positive 6i, and then my inner, when I did negative 6i times 3, I know they're going to cancel out. So I'm not going to write them this time because I know that they're going to add up to 0. So I'm only going to write out my first and my last. Because, again, I know that when I do first, outer, inner, last, I know that the outer and the inner are going to add up to be 0. That's the whole point of using the conjugate, is so that those middle terms add up to be 0. So I'm only going to look at my first, which is 25, and my last, which is positive 5i times negative 5i is negative 25i squared. Now I know that I squared is equal to negative 1. So on top I have still 20 minus 20i. On the bottom, I'm going to have 25 minus 25 times negative 1, which 25 minus a negative 25, actually let me write that part out. So I have 20 minus 20i over 25 minus negative 25. I'll continue down here. 20 minus 20i, and 25 minus a negative is the same as 25 plus. So I have 25 plus 25, which is 50. Now again, I can do some canceling, right? I notice that these are all multiples of 10. Right? They're all multiples of 2, they're all multiples of 5, but the greatest common factor of all of them is 10. So I can take a 10 out on top, and I get 2 minus 2i. Think of it kind of like the backwards process of distributing. I'm undistributing, I'm factoring out. And then on the bottom, I can rewrite 50 as 10 times 5. 10 over 10 is equal to 1. So I'm left with 2 minus 2i over 5. Right, so we did the same process here. We multiplied by the conjugate on the top and bottom. We did that so that the outer and inner terms would cancel, which are our I terms, and we'd just be left with this on the bottom. Then we replaced the I squared with a negative 1. We multiplied 25 times negative 1 to give us negative 25. Then when you subtract a negative, it's the same as adding, so we added them together. And then we saw that all 3 terms, the 2 on the top and the 1 on the bottom, are all multiples of 10. So I factored out a 10, and just to check that, 10 times 2 is 20. 10 times negative 2i is negative 20i, so it checks out. I factored correctly. Then on the bottom, I rewrite my 50 as 10 times 5. That way I get 10 over 10, which just equals 1, so I can cross them out, and I'm left with my answer.